Welcome to the explainer. So you're building automated flows, interacting with forms, logins, basically anything protected by a CAPTCHA. You might think that seeing a simple solved status means, hey, job's done. But honestly, getting that solved checkmark is really only half the battle when you actually move into a production environment. Today, we're walking through the definitive pre-flight checklist for building a rock-solid, resilient CAPTCHA workflow using Cloudflare Durable Object State. Because here's a pretty brutal reality that a lot of developers figure out the hard way. A CAPTCHA solved does not always mean your workflow is actually completed. When you transition to unattended workflows, things like scheduled cron jobs or back-end internal queues, weak points in your architecture are instantly exposed. You're going to start seeing false successes, retry storms that just completely burn through your API balances, and worst of all, downstream rejections where your system is proudly claiming the CAPTCHA was solved, but the protected action still fails completely. The difference here is basically night and day. We've all been there. In a Happy Path demo, solving a CAPTCHA looks deceptively simple. You're in a local notebook script, you capture some inputs, submit a request, grab a token, and boom, you're done in 5 minutes. But unintended production? Totally different beast. A real resilient system running on Cloudflare Workers and durable objects has to survive deploy windows, network hiccups, and scale gracefully, all without you sitting there holding its hand. All right, let's get right into our roadmap. We are covering defining ownership, mapping inputs and context, setting clear state transitions, controlling your polling loops, and measuring and troubleshooting.
Step 1. Define durable object ownership and safe scope.
Before you write a single line of code, we have to talk about authorization. Look, automation should only exist where it is explicitly allowed, period. A safe scope means you either own the application that's rendering the CAPTCHA, you're doing this for a client who gave you the green light, or you have a formal authorized data collection agreement in place. If your setup doesn't fit into one of those 3 buckets, you literally need to stop right here before adding any more automation. Now, once you're safely scoped, you need to lock down what your durable object actually owns. Don't let it become this hidden black box where failures just vanish into the void. It needs to act as a strict state coordinator. Basically, your durable object should be able to answer this exact question at any given millisecond. What is the current state of this CAPTCHA task and what should happen next? If it can't tell you that, your architecture definitely needs some tweaking. Moving right along to step 2, required inputs and session context. Here is the golden rule. Capture only what the solver actually needs. Usually that just means inspecting the live page or the network call and pulling the site key, the page URL, the action, and maybe an optional proxy. That's it. Do not, and I mean do not, store extra page data just because it happens to be available to you. Throwing junk fields into your state just creates these completely false debugging trails, making the workflow an absolute nightmare for whoever has to maintain it next. Keep it clean. And keeping things pristine absolutely applies to the session itself. Think about the session that triggers the challenge versus the session where you apply the token. A solved token is almost always tied directly to the exact context that triggered the challenge. So, if the challenge happens in one browser context or cookie jar, but you try to apply the solved token from totally left field, downstream verification is going to instantly reject it. Mismatched sessions are easily the most common cause of post-solve rejections. Okay, step 3, map clear state transitions. Now that we've got clean inputs and a solid session, we have to explicitly track the workflow inside the durable object. Please, whatever you do, avoid vague statuses. Never just label a state processing. When an unattended CI job fails at 3 a.m. and your pager is blowing up, your team needs to know exactly where the break happened. Use really granular, clear states. Created, submitted, waiting, polling, solved, applied, accepted, failed, or expired. Did it break before submission? During polling? Clear states eliminate the guesswork so you can actually fix it and go back to sleep.
Which brings us to step 4, control your polling loops.
Many CAPTCHA solving APIs use a submit in poll pattern. You submit a task, wait, check for the results, and exit. But this requires strict mathematical boundaries. And to avoid disaster, there is one single number you need to burn into your brain, 120. A 120-second hard cap per task. This is your ultimate safety net. Without a hard cap, a stalled task could literally trap your durable object in an infinite loop, just devouring compute time and resources. So how do we stay safely within that 120-second boundary? You need a really disciplined polling cadence. The Captcha AI documentation gives us a perfectly balanced rhythm for this. First, submit the task. Second, wait exactly 15 seconds before your very first poll. Give the solver time to actually work, right? And third, poll every 5 seconds after that. This cadence perfectly balances API load with workflow speed. You aren't over-polling and creating noise, but you aren't under-polling and slowing things down either. Oh, and cap your retries at 3, using an exponential backoff strategy. I honestly cannot stress this enough. Infinite retries do absolutely nothing but hide real defects in your code, and they will rapidly burn through your account balance. If a CAPTCHA fails 3 times, it's time to log a terminal failure, ping your monitoring channel, and figure out what is really going wrong. And that leads us nicely into our final step, step 5, measure success and troubleshoot. You know the saying, if you can't measure it, you can't defend it. You've got to wire these key performance indicators directly into your application dashboard. Keep an eye on your first solve latency. For instance, your P50 should ideally be under 25 seconds for token CAPTCHAs and under 8 for OCR. And tracking both solver success and downstream acceptance is absolutely vital. They are 2 very different metrics. Watching the gap between them lets you spot system regressions long before your end users even notice a glitch. But hey, when issues do pop up, don't panic. The docs note that roughly 90% of support tickets boil down to these specific errors. And the best part? They are almost all one-line fixes you can handle right from your editor. Seeing an error_0 balance? Just top up your account. Error_page URL. Go revalidate your input against the live HTML. Error wrong user key? Double-check your CI secrets for some stray white space. If you're using the clear state transitions we talked about earlier, you'll know exactly which of these to look for. And this brilliantly illustrates the core takeaway of today's explainer, the crucial difference between a simple solved token and a truly successful workflow. End-to-end acceptance means the downstream verification accepts the token in the exact same logical session it was applied in. Your system doesn't just get a shiny little checkmark, it actually completes the protected action it set out to perform in the first place. That is the true goal of your Cloudflare Durable Objects implementation. So I want to leave you with something to ponder as you go back and review your own architectures. If a token is technically solved but downstream rejects it because of a session mismatch or a clunky state handoff, is your workflow truly successful? Build with clear scopes, precise inputs, exact states, and strict polling limits, and I promise you will never have to guess the answer. Thanks for hanging out for this explainer, and happy building.